This is review lesson 5, our final lesson of our review on expanding and solving equations. So the first thing we're going to focus on is like terms. So what does it mean to collect like terms? Well, when we're doing this, all we need to do is add or subtract the coefficients Okay, and remember that the coefficients are the numbers in front of the variable. Okay, and we're adding and subtracting the coefficients of terms that have the same variables and the same exponents. Very, very important. We can't add or subtract the coefficients if the terms are not like terms. So for example, here we have 2a plus 3a. We can see that both variables are a's and both exponents are just 1's because we can't see them. So those are like terms. So all we're going to do is add the coefficients. So 2 plus 3 is obviously 5, and just carry along the variable there. Okay, so a couple more examples here. So you can choose again. You can rewrite this out so you have the like terms beside each other, or you can just highlight, underline, box, circle, whatever's easiest for you. Just remember that if there's a sign in front, that you also bring that with you. So I've underlined my 2a terms, and there's my 2b terms. So again, all I'm going to do is add or subtract the coefficients. So I have 3 minus 5 for my a's, so that is obviously negative 2a. And for my b's, I have negative 2 plus b, which is going to leave me with just negative 1b or negative b. Okay, so a bit more of a complex example over here, but the exact same method. So I'm going to start by just highlighting, circling, whatever's easiest for you. I have colors, so I'm just going to show you that way. I have an x squared there, and an x squared there, an x and an x, and I have two constant terms here, or two integer terms rather. So for my x squareds, I have 2 minus 4, so that's going to give me negative 2x squared. Notice the variable and the exponent are not changing. I'm just dealing with the coefficients here. For my x's, I have 3 plus 5, so that's plus 8x. And I have negative 6 plus 7, which is just positive 1. Okay, and that's fully simplified because x squared and x are not like terms. They don't have the same variable and the same exponent. All right, so let's move on here. We're going to look at the distributive property, which you might know as the rainbow method. So when we're using this, we're going to multiply each term of the binomial by the monomial. Okay, and you should have heard these terms before, but just as a review, a binomial has two terms and a monomial is just one term. So if we look at our boxed example here, we can see that our monomial is a and our binomial is b plus c. So this rainbow method, what it means is we're multiplying each term in the brackets by the term outside of the bracket. So you might remember your teacher using kind of this little rainbow method, which basically just helps us remember what we're doing. Okay, and it just means a times b is going to be ab plus a times c, which is just ac. Okay, so let's look at some examples with actual numbers. So again, I always draw these little rainbow type things just to remind me of what I am doing. So we have negative 2a times 3a. Okay, so first we're just going to multiply out our integers. So negative 2 times 3 is negative 6. Okay, and then we have a times a. So this is going to be something you're going to want to know. Remember, a times a is not 2a, it's a squared. Okay, so here we have negative 6a squared. And now we're looking at our second term. We're multiplying negative 2a times negative 2b. So first I'm just going to start with the integers there, or the coefficients. Negative 2 times negative 2 is positive 4. And a times b is just going to be ab. And again, these are not like terms, so I'm done. That's simplified as far as I can go. Okay, so let's look at the second one here. So we have 2x minus bracket x minus 8y bracket minus 3y. So again, remember, when we don't see anything in front of the brackets here, we're imagining that there's a 1 there. Okay, because there's one of that bracket. So the first thing we're going to do is multiply that negative 1 into our bracket using our distributive property. So I'm going to leave the 2x alone for now. 2x. Okay, we have negative 1 times x. That's just going to be negative 1x, or negative x. Negative 1 times negative 8y is going to give us positive 8y. And then we have our minus 3y. Notice how I didn't distribute that negative 1 all the way to this term negative 3y, which is outside of the brackets. It only goes to what's inside the bracket beside it. So that negative 3y is not affected. Okay, now we can simply collect like terms, right? We have 2x's there, and we have 2y terms there. So we can simplify this a little further. We have 2x minus x, so that's just going to leave us with the 1x. And we have positive 8 minus 3, which leaves us with positive 5y. Okay, again, we can't combine x and y, so that is fully simplified. Okay, third method or topic we're going to be discussing is multiplying binomials. So remember, up here we were multiplying a monomial by a binomial. Here we have two binomials. So what do we do when we have two binomials right beside each other? Okay, well, you may have heard of this method called FOIL. So as you can see, it's an acronym. Okay, we have it down the side here. So what we're going to do is we're going to start by multiplying the first terms in each bracket together. Okay, the O, now we're going to multiply the outside terms in each bracket together. I stands for inside, so we're going to multiply the inside terms. My apologies for this messy writing in here. And lastly, we're going to multiply the last terms in each bracket together. Okay, so this is very similar to that distributive property. Okay, but this time we have two binomials. So I'm just simply going to follow my steps. So FOIL means first. The F stands for first. So I'm going to use orange for that. So orange for F. So the first term here is A, and the first term in my second one is C. Okay, so A times C, which is going to give me AC. Okay, the second says to multiply the outside. So I'll do yellow. So the outside means A times D, which is obviously AD. Okay, then we need to multiply the inside two terms, so that's B and C here in green. So plus BC. And lastly, we need to multiply whatever's basically left over here. So we have B times D. So plus BD. And when I do this, I don't necessarily do it in that exact order. You just have to make sure that you've multiplied both terms in the first bracket by both terms in the second bracket, essentially. Okay, so it's not a huge deal if you don't do that in the exact order. Just make sure everything is being multiplied together. Okay, so for the example here, I'm just going to draw my arrows. I don't necessarily care what order I do it in because the order really doesn't matter. So first I have 2a times negative 3a. That's going to give me negative 6a squared, right? Because a times a is a squared. Now I'm going to do 2a times negative 2b. That's going to give me negative 4ab. Okay, now I'm moving on to my second term in my first monomial. So 4b times negative 3a is going to give me negative 12ab, or ba. Doesn't matter what order it's in, that would be the same thing. And then my last terms here, I have 4b times negative 2b, so that's going to be negative 8b squared. And we can see that we do actually have like terms here, so we can simplify this one step further. So negative 6a squared. Negative 4 minus 12 is going to give me negative 16ab minus 8b squared. Okay, and then again, that's fully simplified because we no longer have any like terms there. Okay, we'll do one more example here. So again, the order you use in is up to you, as long as you remember to multiply all terms together. So again, I'm going to just follow along. Actually, I'll follow along with FOIL this time. So the first two terms multiplied together. So 2x squared times 3x. Okay, so 2 times 3 is 6. This is a bit different, right? We have x squared times x. We're simply just going to add the exponents together. So we have x squared and x to the power of 1. So that's going to give me x to the power of 3. Okay, next I need to multiply the outside. So that's 2x squared plus 5. Maybe I do actually do it in order here. 2x squared times 5. So that's going to give me 10x squared. Now I'm going to do the inside, which is negative x. Don't forget that negative, times 3x. So that's going to be negative 3x squared. And then our last terms, which is negative x times positive 5, which is going to be negative 5x. Okay, so again, we can see that we actually have like terms here. We have 2x squared terms, so we can simplify that a bit further. So we have 6x to the power of 3. 10 minus 3 is 7. Don't forget to write out that x squared minus 5x. And now we are fully simplified. Okay, last part here. So solving linear equations algebraically. Again, this should all be review. I just taught grade 9, and a lot of these concepts are actually from grade 9, so I assume you used them in grade 10, but if not, this should kind of refresh your memory. So solving linear equations algebraically. We're going to eliminate fractions by multiplying each term in the equation by the lowest common denominator. We're going to eliminate any brackets by using our distributive property. Okay, and then we're going to rearrange the equation to isolate the variable. Isolate the variable. Okay, so let's do some examples then. So here we don't have any fractions, so we don't have to worry about multiplying by that lowest common denominator. We are going to move on to step 2, which is to use our distributive property. Okay, so again, distributing in this case, the monomial to the binomial. So we have negative 3 times x, that's just going to give us negative 3x. Negative 3 times positive 2 is negative 6. And again, we're not distributing to whatever's outside of the brackets here. I'm just copying it down. Okay, and that equals 4 times 2 is 8. 4 times negative 5 is negative 20x. Okay, at this point, all we need to do is rearrange the equation to isolate the variable. So what I'm going to do, my x terms to the left. And I actually shouldn't have even put this equal sign here because this is an equation. It already has an equal sign. Okay. So I'm going to move all of my x's to the left-hand side. So I have negative 3x already over there, another negative 3x. When I move my 20 over the equal sign, it's going to become positive 20x. Okay. I'm going to move all my integers, which is just whole numbers, right, to the right-hand side. So I already have an 8 over there. I'm going to move my negative 6 over. It's going to become positive. Now I have my like terms all together. I just have to collect them and simplify. So negative 3 minus 3 is negative 6x plus 20x is going to give me 14x. And 8 plus 6 is also 14. Remember, I need to get x all by itself, right? My third step here was to isolate the variable. So in order to get x by itself here, I'm going to use opposite operations. So I need to actually divide by 14. What I do one side, I have to do to the other. These 14s are going to cancel out. I'm left with just 1x. And in this case, 14 divided by 14 is actually just 1. So in this case, x equals 1. And remember, when we're solving an equation, our goal is to end up with x equals something or y equals something, whatever the variable is you're solving for. Okay, so one last example here. So in this case, we do actually have fractions. So the first thing we need to do is multiply every term by the lowest common denominator. So the lowest common denominator, in order to find that, in this case, I'm just going to do 3 times 4, which is 12, right? That means 3 goes into 12 and 4 goes into 12. So what I'm going to do, I'm just going to write these in brackets. And I'm going to multiply both sides by 12. So when I do this, pay close attention here. 12, I'm just going to leave the numerator kind of alone here. But basically, first I'm going to look at this. 12 divided by 3. Okay, well, 12 divided by 3 is just 4, right? So these actually cancel. They don't cancel out fully, but I can do that math. 12 divided by 3 is just 4. And I'm just left now with my numerator. 4 times y minus 7. Okay, same thing over here. Again, they're not canceling out because they equal 1, but we can simplify it. Essentially, that's all we're doing. So 12 divided by 4 is 3. So again, I'm left with just the numerator. And that's because I multiplied by my lowest common denominator. So now I'm good. All my fractions are gone. This is something easy that I can work with. So I'm going to move on to my second step, which is to use my distributive property. 4 times y is 4y. 4 times negative 7 is negative 28. 3 times y is 3y. And 3 times negative 2 is negative 6. Okay, third step here. You even might want to label these. 1, 2, 3. Third step is to rearrange the equation to isolate the variable. So again, I'm going to just move all my y's to the left-hand side. It doesn't really matter if you choose to move them to the right-hand side. It doesn't really make a difference. I'm just going to choose to move them to the left because I like when it says like x equals or y equals a number. So here I have 4y. Okay, again, when I move something over the equal sign, I need to change its sign. So negative 3y. And over here, I already had negative 6. And I need to add 28 because I'm going over that equal sign. 4 minus 3 is just going to give me 1. Negative 6 plus 28 is 22. So I've solved this equation. Y is equal to 22. Okay, and that is the end of this note and the end of our review.